My name is Stefan Frübert. I'm the team leader of the team Mechanical Disintegration at WoodK+. I've been working for almost 10 years on the development of the perfect cutting force measuring stand. In the research project Hardis, financed by Interreg Austria and Czech Republic, we, the Mendel University Brno and WoodK+ Austria, have developed a worldwide unique test rig for the detailed investigation of cutting processes. A better understanding of the cutting process is the basic prerequisite for a knowledge-based approach to increase the efficiency and effectiveness of machining processes. The knowledge gained in Hardis should provide the necessary basic knowledge. The developed test device allows the investigation of the extremely complex processes involved during wood cutting. The high cutting speeds of 100 meters per second and more used in wood processing push even the most modern measuring technology to its limits. In order to meet this challenge, we have therefore reversed the process of cutting. So here it is not the cutting edge that is moved, but the workpiece. The workpiece is guided past the stationary cutting edge at speeds of up to 100 meters per second, and the resulting cutting process is measured using state-of-the-art sensor technology. This reversal enables a detailed examination of the cutting process along a defined growth direction. As the rotor arm must rotate at up to 8 revolutions per second to achieve the high cutting speeds, one of the main challenges was to optimize the aerodynamic properties and at the same time maximize the rigidity of the rotor arm. Yeah, this is the worst structure ever, which we had in the beginning.
Displacement is really big in the end. So we added material just in the right points, but weight increased a lot.
So that's why we ended up with this aerodynamic optimized version, which should look like that.
The airflow simply goes around because it has the edges of 45 degrees. Yeah, it can nicely move through the air and
it will revolutionize our Hardis device. Since summer 2019, the Hardis device has been providing highly accurate insights into the processes occurring during the disintegration of wood, thus enabling the identification of correlations between various process, tool and raw material parameters.
The acquisition has started.
To enable highly accurate cutting force measurements, it is necessary to optimize the dynamic properties of the entire measurement setup. Subsequently, the dynamic properties of the entire measuring chain had to be determined, as these form the basis for the subsequent data correction. By knowing the dynamic properties of the measuring chain, the actually occurring cutting forces can be calculated. For this purpose, a so-called inverse filter is calculated from the determined frequency response, which is then used for subsequent data correction. With the help of the inverse filter, interfering frequencies can be removed from the signal, allowing the actual cutting process to be displayed without distortion of the measurement signal. Using high-speed cameras and digital image correlation, the resulting deformations are measured parallel to the occurring forces. In order to better understand the behavior of wood at high loading rates, The dynamic mechanical properties were determined parallel to the cutting tests. For this purpose, compression and tensile tests were carried out by means of a split Hopkinson bar. Based on the knowledge gained, relationships between tool, process and material parameters can be identified. This allows the simulation of cutting processes and the optimization of tool and process design. The results of the project Hardis help to minimize time and cost-intensive tests. Thereby, the development of efficient disintegration technologies can be significantly accelerated. The Hardis project with the project number AT-CZ21 was made possible through the Interreg Austria-Czech Republic program line in cooperation with the European Union and financial support from the province of Lower Austria.